Hello there. Hello. Loud. Come on. I thought I'm the one who's tired. I'm in a different time zone. You guys are still in Spain time zone. Yeah, well, that's why we just fed you with coffee. Caffeine, guys. Come on, load it up. Anyway, so hopefully the steroids will help you in that case. So my name is Arun Gupta, and I work for Oracle. I'm going to talk about JAX-RS. How many of you know what JAX-RS is? Okay, quite a few of you. So in this talk, what I'll do is I'll give a quick introduction of JAX-RS. It's a standard way of building RESTful web services in the Java platform. So I'll talk about what does that standard way give you, and then I'll talk about what are the new features coming in the next version of JAX-RS. This is my blog URL. I will actually post the slides all over here. Lawyer slide, not much to be said about this, but I'm not going to read it. But the idea is the timelines are only indicative. They can change. That's the only ballpark here. So let's see, how we got here in terms of JAX-RS. So JAX-RS is really a standard way of building RESTful web services in the Java platform. Going by the RESTful principles, everything is considered as a resource. You access a resource, and you want to do something with the resource. What do you want to do with the resource? Those are again defined by standard verbs. You possibly want to create, update, delete, get the resource. So those are typical CRUD verbs. So everything is assigned an ID. There are common set of methods, and the resources are linked with each other. For example, a customer places an order, so you got a connection between the two resources. So you define those linking. Each resource could be represented in multiple ways, depending upon what your end client device is. It's a browser, it's a mobile phone, it's a desktop. Could give a different client representation, richer or lesser representation. And the communication is stateless. In the sense there is no state that is being stored on the server side. Client gives the whole information, server processes it and returns it back. Something else is required, client has to send that information again. That's a typical, those are sort of the basic tenets of RESTful architecture. Now, how does JAX-RS fit in there? JAX-RS allows you to do all of those principles very easily, implements all of those principles. So you take a POJO object, plain old Java object. On that POJO, it's a server-side API. So it allows you to take a POJO, publish it as a RESTful resource very easily. How would you do that? You put an annotation on it. So take a POJO, put an annotation on it, say I want to expose this POJO as a RESTful resource. So how do you want to expose it as a resource? You give it a path. So you put the add path annotation over there. The API is purely HTTP centric. That's the prevalent protocol for doing RESTful web services. It's format independence. What that means is you can take a POJO, you publish it at a path. Now you want to publish it in different formats: JSON, HTML, XML, text, anything of that sort. So your POJO does not depend upon what format is going to be generated. You can just tweak that conveniently using just a single annotation as well. The API itself is container independent, so it could run in any of the containers. Java EE, non-Java EE containers would work very well. So Tomcat, for instance, it would work very well over there. However, JAX-RS is itself included as part of the Java EE platform, so which makes it much more relevant. So if you are building your applications using Java EE APIs, that means you have that functionality available to you as part of the platform, the API and the runtime. Code is king. It's always much easier to explain using code. So just look at the black code to begin with. Public class ATM service, public balance, string card, string pin, and then you got a return which is saying double toString get balance, giving a card and a pin. Now that's not how you will code your business code though. You will not pass card and pin as a clear text as parameters. But this is just to highlight the point. So now that's my simple POJO. Now my goal is I want to expose this POJO or publish this POJO as a RESTful web service. How would I do that? On the POJO, I'll put a add path annotation. I'm saying this ATM service is now available as a RESTful web service. Add the path /ATM, and then within curly braces, I'm saying card ID. What that means is this is the fixed part of the URL. This is the variable part of the URL. Now this variable part over here, card ID, gets mapped to my add path param, which is add path param card ID over here. So if you invoke this service, say /ATM /111222, then that /111222, or actually just the 111222, gets mapped to the method parameter over here. Card number is available to you over here, which you are then actually using in your business logic over here. Now, in addition to /ATM /card ID, you could also say question mark name value pair. And then you could say question mark pin equals to, you can give your card pin over there. That gets mapped to the method parameter as well using add query param, for example. So whatever value you give in the URL is conveniently mapped for you to the method parameters very easily over here. Now here is returning double toString, it's a double, but the return type over here is string. Okay, so what we are saying is this method is going to return a string, is producing a text/plain representation. By default, there is no MIME type that is defined, but in this case, you are saying I'm going to return a text/plain representation. You're also saying, oh, by the way, this is the method that needs to be invoked when this resource is actually accessed using HTTP GET. We talked about standard verbs, standard methods that operate on a resource. So get, put, post, delete are the 4 standard verbs in the HTTP terminology. So when you access this resource, ATM service, using HTTP GET, this is the method that gets invoked. And this method is also a sub-resource, by the way. What that means is, in order for this method to be invoked, you need to say /ATM /card number /balance. So that is your complete path of the resource. Now, also think about this POJO would be bundled in possibly a WAR file, and that is deployed on a container or an app server. So effectively, the complete path of the resource would be your host, :port, / whatever your context root is, / then comes all of this, ATM card ID /balance. So that's where your RESTful resource would be accessible. So talk a little bit more about it. This is more diagram. These are my paths: main resource, sub-resource. Quick summary. This is my built-in serialization. All I'm saying is return type string, and I'm putting produces text/plain. Now here, I'm saying a standard MIME type, but we are not really restricting it to standard MIME types only. It could very easily be a custom MIME type. So for example, I think I showed that in the next slide. I talked about how the URI parameter injection actually happens, both from the path and the name value pairs, which are the query parameters. I talked about the HTTP method get binding. So you have a get method. This is the method that needs to be invoked. And then we talked about custom serialization. So for example, that was a balance method. This is a withdraw method. So here I could say, for example, this method to be invoked when HTTP post is being called. And then I'm also saying this is my sub-resource, which is at path /withdrawal. I'm saying consumes text/plain. That means I take in a text/plain as part of my post body. So you can define the MIME type. Typically you get your post. Post could have a plain or HTML or JSON, whatever type it is. You are specifying the type over here. And then here you're saying the output return type is going to be application/JSON. Now how that works? So here I have a public money. The path param, query param is still the same. So here, when you say money, money is possibly your POJO. On that POJO, you have a JAXB annotation, and JAXB knows how to convert, for example, XML to Java and vice versa. Using a convention, the Jersey implementation actually automatically converts that Java to JSON for you. That's something hidden in the JAXB layer itself for you. So the idea is all this method as is, using the underlying layers of the stack, the custom serialization work as well. Now, one more point to highlight here. So here, for example, I'm saying application/JSON. That's a standard MIME type. What if I want to define my custom MIME type? You can do that too. So for that, the JAX-RS API provides something called as message bean readers and message bean writers. So you can define your custom MIME types, and in those custom readers and writers, you define how your MIME type needs to be read and written. So to the stream and from the stream. So with that JAX-RS 1.1 background, this is a set of features that was actually requested in JAX-RS 2.0. This is primarily coming from the expert group, from the use cases, from the users who are actually using it. So that's where it's coming from. The first is the client API. Now, as I said, JAX-RS 1.1 is a server-side API. So you have a POJO, you want to publish it as a RESTful resource, you can do that very easily. Well, you can write all of that code using servlet as well, but what that means is you will have to parse the entire request by yourself. You have to parse, oh, it's a GET request, and you have to figure out the spacing, and then you have to start mapping the method parameters, parsing them, doing the validation, etc. So you could do all that code in servlet, but the POJO-based annotation-driven model makes it much simpler for you. Same thing on the client side. So you could invoke a RESTful resource as well. You have to write a java.net code. So you say, get me the URL, open the connection, handcraft the message, and this is a GET, and I want to add specific HTTP headers. All of that crafting needs to be done. Client API makes it simple for you, simple and easy to use, basically reusing the existing concepts, and we'll talk more details. Filters/handlers or interceptors, the term keeps changing, but they allow you to do the pre-processing and post-processing of request and response. Typical examples over there are logging, gzipping, ungzipping, and things like that, sort of doing your aspect-oriented stuff. Hypermedia is a way by which you can link the resources together, and you have access to the links in your resources. So think about getting an XML request, which has bunch of customer IDs over there. Now, if you want to get the next customer, or let's say you want to get more details about the customer ID, how would you do? How would you get it? So you will need to somehow extract the customer ID from there, and then say, get me more representation of this. So that's where hypermedia would be utilized. JSR 330 is a standard way of doing injection in the Java EE platform, so much tighter integration with that, allowing you to do asynchrony, both on the server side and on the client side, so that you're not tied. Your resources are much more available. This allows you to scale much better. Validation is a very relevant use case. Think about an HTML form that you could submit to a RESTful endpoint. Now, just the way we have path param, query param, I could also have a form param. What that means is my HTML form, let's say, has 3 fields. Each field could then map to a parameter of the method. So you could say add form param and map it accordingly. And there, you want to do validation, for example. So you could do client-side validation with bean validation integration, and I'll show samples of this. You can actually do server-side validation as well. Now, each POJO, when it has a method or when it is exposed as a HTTP verb, can publish multiple MIME types. It's not restricted to just one MIME type. You can say, yeah, this message can return text, JSON, HTML, different MIME types. So today what happens is client basically says, oh, this is a MIME type that I want, and that's how the content negotiation happens. Excuse me. Now, but if the server is returning multiple MIME types and the client does not say any preference, what does the server do? Server is free. So it's not a consistent behavior. So we are improving connection negotiation in that part of it, and I'll cover that. So with that set of features requested, the expert group was formed March of 2011. Oracle is the Java specification request leads over there. Expert group is quite a varied expert group, actually mostly consultants who are actually using this JAX-RS in their day-to-day life. The early draft was published recently, literally last month. So that's pretty cool. So I think one important part to realize is, and that's what Oracle is trying to change. That's what JCP is trying to change. JCP always had this impression of an ivory tower. That, hey, this is an ivory tower. Whatever happens inside it, they throw out the specification and people take a look at it. We're trying to change that. The complete list of expert group members is visible. The complete discussion on the expert group alias is visible. All the specifications, all the source code is visible. So, for example, you could go to JAX-RS-spec.java.net, and then you can download the spec, look at the expert group discussions, all of that, participate, contribute your use cases very easily. So let's take a look. Where are we going? Well, one feature I didn't talk about purposely was MVC. Now, think about, you have your POJO, which is a RESTful endpoint. One of the use cases that was proposed and discussed within the expert group was that following the MVC architecture, your RESTful endpoint could be the controller. Your JPA could be the model, and you could have multiple templating. I mean, JPA is one possible model, and then you could have multiple templating languages, say JSP, facelets, velocity, whatever it is. So one of the thoughts that was considered is within the JAX-RS specification, we should talk about how there could be multiple templating languages in the front, multiple data models at the back with a REST controller. That was considered out of scope because it involved too much coordination with other specifications as well. So effectively, we just stayed with these features, and these features that's what we're working upon right now. Let's get more details. Client API. So as I said, the HTTP client libraries are way too low level. That's sort of the biggest motivation. Instead of you working with java.net, creating a URL connection, doing a GET, putting the actual request method over there, making sure the appropriate spacing is done, forming a body, receiving all the HTTP error codes, handling them and all those things, just provide a higher level API. JAX-RS Server API already has the concept of message bin readers and writers, which allows you to do custom MIME type mapping. So utilize those concepts. And other part was several JAX-RS implementations already provide a client-side API. Non-portable, but they have their own client-side implementations. So the idea was to provide a standard API on it, which everybody can use. Let's see how our client API look. So you start with a client factory, you say, give me a new client. Now that's just one of the proposed ways. But what you could also do is you could say add client, for example, or add inject client. So then it would automatically inject the client for you. So instead of you saying client factory.new client, it would automatically inject the client for you. And there possibly you could right away say, oh, give me the resource for which this client is injected. So all that instantiation, configuration, management will be done by the runtime container itself, instead of you managing client factory, for example. Now once you get the client, you could get you can set the target on it. This is the URL that I want to invoke. Then you say the path param, card. No, not a real number, don't try this. This is a query param, which is what get converted into name value pairs, like question mark name equals value. And then you're saying, I want to accept responses, which is text/plain. And then I'm saying, I'm invoking get on this resource, and I want to get string as a response back. So that's sort of how the query looks like. This is a builder pattern. If you have to write this much code just using Java.NET APIs, and I should have actually brought that blog with me, it's a lot more verbose. Another example, how would you do post? Same thing, client target, path param, query param, request. I'm saying I want application/JSON back. I want to make a post request, and I want to get the money class back. And you get the money here. So it's very intuitive Java model. Just use the builder pattern, build your API, and fire it. Those are static calls. You could also do dynamic calls, wherein, let's say you want to invoke a whole bunch of RESTful web services. So you could make an array of invocation. So for example, you could say client.target, it's a generic invocation class here. You say client.target this, request this, you say build a get request. So you get a generic build request over here. Then you can similarly build a post request. And then once you have a bunch of those generic requests, you can just fire them. So you have a collection of invocation, arrays as list, say invocation 1, invocation 2. And then I'm using just a non-standard API, collections.transform. It's a Google API. But the idea is there are other bunch of similar APIs by which you can take those bunch of invocations, fire them, and say, get me the result back. And then you can do the transformation on the result. That's my client API. Let's take a look at interceptors and handlers. The key point here is, these are well-defined extension points where you can actually do the request pre-processing and response post-processing. Okay? As I said, the typical use cases are logging, compression, security, etc., where you don't want to kind of pollute your POJO by the business. You want to keep the business logic only in the POJO. Everything else that is required outside the POJO goes in your filters and interceptors. They're shared by the client and server APIs. I'll show you samples for these. And again, one of the big motivations was a lot of different JAX-RS implementations were already supporting filters and interceptors. So having a standard API really helps that way. Now, the big difference between really filters and interceptors / handlers is filters are non-wrapping extension points. In the sense, you invoke a filter, it will not modify the body of the request or the response. Logging is a typical use case. So you can say, what, I just want to log the request, take it, dump it on the console, on a log file, or whatever. That's what I'm going to do. So that's a typical request. That's a typical filter. Each filter is part of a filter chain. They do not call the next filter directly. All they say is, yes, I want to move on. There's a higher level filter chain that says, okay, this filter has returned, let me call the next filter, basically. So that's how we go. So you return filter action.next or filter action.stop, depending upon if you want to break the logic, and that's how the whole filter chain is being worked. In case of a sample code, so here I have a public class logging filter. Public is missing. Public class logging filter implements request and response filter. Standard interfaces defined in the specification itself. Those interfaces actually gives you two methods, pre-filter and post-filter. And pre-filter, they both return filter action, which are of the type next or stop, as I was saying. So each filter says whether I want to stop the processing or keep moving on. And then they both give a filter context as a parameter, pre and post filter. In here, all I'm doing is simple log request. I say context.getRequest, just dump the request, and say return back. So call the next filter in the chain. Similarly, in post filter, same thing. I get a filter context, I log the response, and I say return filter action.next, and that's it. And this is where I get context.getResponse. So on the request and on the response side, I can do the logging very easily. Interceptors, as I said, on the other hand, or handlers, are the wrapping extension points. They can actually change the body of the request and the response. So gzip is a typical use case. So for example, you want to gzip your entire request. You want to speed up, let's say your request is big. So you can easily put a gzip filter, a gzip interceptor in there. It will automatically change the body. And then on the response side, you can ungzip it, for example, and reverse on the coming back. So you can easily do that. They're all part of our interceptor chain. They call the next handler directly by calling context.proceed. So let's take a look at the sample code. So I have a public class GzipInterceptor here. Same thing. I have a reader interceptor, a writer interceptor. In here, I have, these method names are very ugly to me, frankly. Around, read, from. Doesn't make sense. So please file a bug for this. At least I will. Public object around, read, from. That's sort of the latest method in the early draft. And then I have a read interceptor context. Now in this, just the way we had a filter context, we get an interceptor context. And in here, I could check whether the request is already gzipped or not gzipped, and then I can take an action. So this is where exactly, I'm actually changing, see on the context, I'm saying setting the input stream, and this will take care of actually modifying my request itself. Something else to be aware of is like how filters and handlers are actually executed. So this is, let's say my client is sitting here, and let's say this is my endpoint. So my client issues a request. It says the filter gets executed, then the handler, then the message goes over the internet or whatever the endpoint is. Before the message is received by the endpoint, filter, handler, actual business logic being done here, then it comes back, filter, handler, all the processing is done, then thrown back to the client, filter, handler, back to the client here. The idea is, in the order of execution, filters are always executed before the handler. That's sort of the ballpark here. Now, once you have defined the filters and the handlers, how do you associate your filters and handlers with a particular POJO? So you define a name binding. This is a new concept that JAX-RS is defining. It's basically a meta annotation, say logged, for example. And in here you're saying, on the logging filter, which is actually doing the business logic, you say this is logged. So you define a meta annotation, you put the meta annotation on your filter itself, and then on the POJO, which is your my resource class exposed at the root, you say logged. Now this is a very simple hello world method, string hello, get a path param, return the response. You're saying log just this method. So this could be either at the method level or at the class level. So if you put at log at the class, then all the methods of the class would be logged. Let's take a look at validation. Now, I talked about how validation is important. So let's say you're taking an HTML form, submitting it to a RESTful endpoint. Typical example, but that's just one use case. What if you want that whenever your methods are invoked, your form params, your method params, your query params, they need to be validated. For example, let's say in our example we say card ID or PIN. Can PIN be string or can card ID be string? Things like that. And what if a string comes? What do? Throw an error back? Or should you do the error validation or somebody else should do the validation? And that's exactly what bean validation simplifies for you. Bean validation defines a standard mechanism by which you can put those validation constraints on a bean, on a method parameter of a bean or anywhere around the method, which will actually honor those constraints. So with that integration of bean validation in JAX-RS, those constraints are actually honored, and if there is an error is thrown back to the client with the appropriate error code, HTTP error code. So the constraints could be either at fields and properties, parameters, methods, or resource classes. Let's take a look. So here is a resource class exposed at the root. This method to be invoked when HTTP post is being called. Application form URL encoded is a standard MIME type. When you submit a form using HTTP post, this is the MIME type that comes to you. Here I have 3 form params: first name, last name, email. All I want is, this is my typical form here. All I'm saying here is at not null, at not null. So I don't want the first name and the last name to be null. Now, you could do this validation on the client side in the form using JavaScript as well. Absolutely. This is just one more layer and one more way by which you are making your form more foolproof. Or let's say if this is not really coming to you from an HTML form itself. Somebody is just manually, through a business process, posting some logic to you. Now, this is the built-in part of it. The interesting part is where you can say at email. This is a custom validation constraint. So here, you're saying, okay, this is string email form param coming from that field of the form, and then you're defining your custom constraint over here. So in the custom constraint, you can do all sort of fun stuff. You can check the format of the email ID. You can talk to the database and see if it's a registered user, or reject example.com or foo.bar.com, things like that. Just a quick example of how the custom constraint would look like. I just define a meta annotation here. It says validated by email validator class. This is my email validator. Implements a standard constraint validator. Then I have an initialize method, and this is my isValid method. In the isValid method is where I get my string value, which is my email, and then on the email, I just get the value and actually do the validation on that. And I return the response. It's a Boolean, so whether it's correct or not correct. This is something that you can do at the class level itself. So for example, let's say you have a POJO with you can put the @CheckUser1 constraint over there. This @CheckUser1 again is a custom constraint as you have defined. You have your POJO here. You're not putting any class or method level annotation here. In the parameter, say you have user u, all you put is @valid. Once the moment you put @valid, this annotation will kick in automatically. Or you can also say, in a different method, @valid and @CheckUser2, for example. You could have a different annotation over there. So you could add more constraints very easily. Let's take a look at async. Now, the typical use case for async is, on the server side, you have a bunch of threads with you. Let's say if you make a request to the RESTful endpoint, do you want it, and you know that, for example, it's going to take a while for it to process the request, either because of a database query, or it's going to talk to an external service, or a workflow. You don't want that thread to be blocked effectively. So that's exactly the idea over here. So you get the request on the server side. You know it's going to be a long-running process, so you suspend. Wait for the process to complete so that the thread is free to receive other requests. And when the processing is done, you resume and give it back to the client. Now, the client is independent of server. Just the server could be asynchronous, or even the client could be asynchronous. And in JAX-RS 2.0, we're introducing both of those APIs for asynchrony. 6 minutes more? Oh, 15 minutes more. Oh, okay. 15, okay. It's a cultural thing, sorry. So let's take an example of suspend and resume. It's funny, how when somebody else claps in a different room, you get a notification. That means that session is finished. So I have a public class, my resource over here, add this path. Now the idea is whenever you try to access it, using @get, this method is started. It's a long-running app. I know that this method is going to take a longer. So all I do is I just do a single thread executor to begin with, run it in a separate thread. In this, I have a runnable method. And in the runnable method, all I'm doing is run. I'm just sleeping for 10 seconds. As simple as that. So I'm sleeping for 10 seconds. And then when the process is done, it's simulating a long-running process. That's the goal. And here in my resource class, I've also injected the execution context of this particular POJO. So whenever I'm done with the long-running process, all I say is context.resume. And then I pass the value, hello async world. So now think about it, how the method executes. You call async long-running using get. It comes to this method. It says, oh, this is a separate thread, so just spin it out over there. It comes over here and says context.suspend. So it just suspends right there. In this thread, which is running over here, it says, okay, I'm going to run for 10 seconds. And when I'm done, I'm going to say context.resume. It comes back here. Oh, this is a context. It resumes. And then this thread is being resumed again and returns a response back. So on the client side, you're literally waiting for 10 seconds, a little bit more probably, because the server side resources are not occupied. That's the server side asynchrony. Now, instead of saying context.suspend, you can also put @suspend annotation over there. So it would know exactly that, okay, you know what? You just want to suspend this request as soon as a new thread is spawned, so it'll just wait for you. We also have client-side asynchrony for you. And the way that works is, we're building a target URI. You get the target URI, then whenever you're making a request, you explicitly make an async request. That is going to give you a future object. Standard JDK 1.6 API. So you say, you get a future object. I'll get to invocation callback, but once you get the future object, future has all those APIs. Is done, cancel, progress, and things like that. So you can wait, or you can say, I don't care about it, just cancel the request. Now, you also pass here a callback object. on the callback object, you say, you provide a couple of methods, complete, failed. If the method is complete, then you get string balance. This is where you get your response, actually. And if the fail, then you get an invocation exception over here. So the idea is you have support for both server-side asynchrony, client-side asynchrony, and you can tie them together to make it really scalable. Excuse me. Let's take a look at hypermedia. Now this is the part that is still under heavy discussions. So it's a little bit fuzzy, in terms of how it needs to be implemented, what would need to be implemented. But if I can explain you, HTOS, it's one of the weird names. It basically says that everything that you want to do for the RESTful web services can be handled by a RESTful web service itself. In the sense, you can make the very first request, give me the list of all the customers. Okay, you get a JSON response back with the array of JSON objects, each of which is a customer. Then you can say, oh, I'm going to go through this list of array of customers. Give me the customer, you got the customer ID. So you say, for this customer ID, show me all the products he has ordered. Or you got all the products. Oh, for this product, show me which shop has shipped it. So the idea is you can do a full conversation just using the RESTful representation itself. Now, in order to achieve that, there are two types of links. There's a structural link and there is a transitional link. Now, the structural link is what is bundled into the message itself. And then there's a transitional link, which basically says how the state is transitioning. So in terms of the message itself, this is where your structural link is. So for example, you have customer/11/11/address, your /products/111. These are your structural links. And these are your transitional links. Go ahead, ship the product, or cancel the product, cancel the shipment, for example. Now, this structural link support requires much more extensive work. We have to work with JAX-B specification, define how this binding is going to work and all that stuff. So that's still under discussion, whether that's still in scope or not. But transitional link, that is going to get supported today. So if I can walk you through that. So here, what you're saying is, on the server side, you're creating a generic response, say, OK, order, and then you're creating a transitional link here, providing it, a ship and a symbolic name, ship. And then you say, build the response. So then you return the response back to the client. On the client side, you say, OK, client.target, I'm requesting application/XML and get. Once you get it, on the order, you just check a method, get link. If there is a ship link over there, so you get your transitional link, then you can actually operate upon it. If not, then you can just ignore it or do the right thing. Talk about content negotiation. So as I said, client, the way client-side content negotiation works, it sends an accept header as part of the request. It's a standard HTTP header. It sends an accept header saying this is how I want, this is the MIME type that I accept. In that accept header, it can also kind of start giving hints. So for example, in this case, it's saying text/star. So give me any text representation. It doesn't matter. It's a standard MIME pattern. By q equals 1, it's saying priority 1. So I want a text representation. So if, for example, on the server side, you have text plain, text HTML, the server doesn't know. Hey, both the priority is 1. So what should I return? So server is free to return any type. But that's inconsistent. You should still have some standard way of returning what is a MIME type. So the way this works is, QS is a standard attribute. So here what we're saying is, on the server side, just like client could say Q, you're saying server side quality of server priority. On the server side, you can assign priority to each of the MIME types. So for example, here I'm saying client is requesting text/star q equals 1. On the server, I'm saying my preferred representation, if the client don't care about, is HTML. So if client sends this, then HTML is a return type. If client does not send this, then even then HTML is a preferred representation. So that way, we can do server-side content negotiation as well. One thing that we didn't touch is better integration with JSR 330. That's because it's still TBD. We're still working on it, how that integration needs to happen. Second room clapping now. Huh? Now, something else that is also under discussion is a high-level client API. Apparently, the client API that is already being proposed, people think that's not high enough. So they are going to the Corba land, or the SOAP-based web services land, where they're saying, oh, we should actually have a stub being generated for us. We should be able to take a look at the RESTful web service and generate a stub, and then that would automatically do all the code generation for me, etc. Not sure it's going to fly through. It's a RESTful world, but we'll see. And this is where you can find all the details of the JSR. This is where you can find the JAX-RS spec itself. This is where all the expert group discussions are happening. And this is the time when you can actually clap. Thank you. And I'll take any questions if you have any questions, by the way. Yeah, that seems to be the most common question, how to implement security using RESTful. OAuth seems to be one of the most common ways actually that I have seen, or transport layer security. Those are the two typical patterns that I have seen. Still, OAuth 1 is the one which is most prominently used. I mean, think about Twitter, Facebook. They all provide OAuth layers very easily. So if you want to use Twitter API, RESTful API, they give you OAuth. Facebook is OAuth 2 actually. So those are the typical patterns that I see. All right, thank you.